the classic maths problem about ages. Right? Teddy is 5 years old. Mari is 4 years older than Terry. Okay, starting off pretty good. So when Teddy is 5, Mari will be 4 years older, so they'll be 9. How many years will it take until Teddy's and Mari's ages, when multiplied together, will make 77? Well, just looking at the numbers, I think 7 and 11, right? 7 times 11 will give 77, and they're 4 years apart, so it will take 2 years. So we're done. No, we're not. Right? We need to show it algebraically. So it is good to have some intuition, and if you don't have that intuition, it's totally fine because we have algebra. We can show it algebraically. But now we know where we're heading. So this unknown, right? What's our unknown? We can introduce this variable. So how many years will it take? So let x be years taken for like their ages to multiply to give 77. All right, I think it's going to be 2, just from guessing at the start. But let's introduce this variable. So we need their ages to multiply, right? So when in algebra, when we have brackets like this next to each other, it's multiply to give us 77. We know Teddy starts off at 5 years old and Mari starts off at 9 years old. And to them, assuming time, they travel through time at the same rate, right? So one's not like traveling near the speed of light in outer space, which is a fair assumption. We can say that we add on to their age this number of years taken for them to multiply to give 77. Right, so when Teddy is 5, Mari is 9. If x was 1, so in 1 year's time, Teddy would be 6, Mari would be 10. Right, they're always 4 years apart. And so here is our equation. Now we can solve for x, essentially, right? So let's FOIL this out. So 5 times 9, 45. 5 times x plus 5x. X times 9 plus 9x. X times x plus x squared. Awesome, so I see a quadratic emerging, right, with the x squared term. So let's take it to standard form. So that's where we have everything on one side of the equation equals 0. So we have x squared. We have 5x plus 9x, that is 14x. We have 45, and then we will minus 77. So 45 minus 77, all equals 0. Now, if you're a bit stuck on, and not too good at your subtraction like me, let's just take this term a bit slowly, because in MCAT we can't use a calculator. So 77 is definitely greater than 45, so we expect a negative number. What I like to do is start at 45 and think, what do I need to add to get 77? So it's 30 will get me 75, and 2, 32. So 45 minus 77 will equal negative 32. Negative 32. Don't need that plus sign anymore. And again, on the arithmetic side of things in an algebra exam, do take your time. Like, we're not testing you on your ability to add two numbers, right? That's assumed, so make sure you get that right. But we're down to here. We have a quadratic equation. Give ourselves a pat on the back. We're nearly there. Now we just need to solve it. So two numbers that multiply to negative 32 and add to positive 14. So 16 and 2 are factors of 32. So we'd need the minus 2 and then the plus 16. Right, it was minus 2 plus 16 gives plus 14. Minus 2 times positive 16 gives negative 32. And then solving for x minus 2 must equal 0, or x plus 16 must equal 0. So x will equal 2, or x will equal negative 16. Interesting. So x would be negative 16. Does that make sense? Can we go back in time? So imagine if we go back 16 years from Terry being 5 years old. His parents probably haven't even met yet. So kind of impractical, which tells me that our solution will be 2 years. So it will take 2 years. And it's very important you can make a conclusion, especially if we're ignoring this negative solution. I mean, it seems pretty obvious, but someone could be reading your work and be thinking, oh yeah, negative 16 years, that makes sense. So do just write that final comment saying it will be 2 years.